Okay, so this question is a binomial distribution question. A binomial distribution happens when you have success or failure outcomes. Either you pass or you don't pass, right? That's a no, wait, they have a word for that. It's a certain type of event. And if you have multiple trials of those pass-fail events, it's binomially distributed. So 65% of the people in Missouri passed the driver's test in the first attempt. So we're told the probability of success, P, is 0.65. A group of 5 people took the test. That means n equals 5. What's the probability that less than 3 in the group pass their driver's test? So that means what's the probability that 0 pass, plus the probability that 1 person passes, plus the probability that 2 people pass, right? That's the event of less than 3. 1 person out of the 3 passes. 1 person out of the 5 people pass. 2 out of the 5, or 0 out of the 5. So that means you got to run the formula 3 times. The probability that 0 people pass means n combined 0. Wait a second. Yeah, and choose 0 would be the right way to say that. And then we're going to plug our probability of 0.65. That's the chances of passing. 0 people are going to do that. We multiply it by the complement, 1 minus 0.65 to the n minus x power. So that's x in this case is 5. I should have put that to begin with. There's 5 people we're picking from. So this is what we got to compute. What this notation means with the parentheses, it means you use the combination formula. So you got 5 factorial, 0 factorial, 5 minus 0 factorial here. And then 0.65, anything to the 0 power is just 1. And then 1 minus 0.65, that means 0.35. To the 5 minus 0 makes 5. So we're getting closer. When you compute this, 0 factorial means 1. Okay, that's the definition, that 0 factorial equals 1. So I got 5 factorial over 5 factorial. That just makes 1. This is 1. And then we found out this is 0.35 to the 5th power, so we can do that with our calculator. 0.35 raised to the 5th is something crazy. I can't really move that over. So the big idea here is that we found the probability of 0. It's about 0.0053. Now you have to run the formula again. Come on, computer. We've done this one. Now we have to do it for the probability of 1. That's where you plug in 1 in for x. So 5 is our n, 1 is our x. It's 0.65 to the 1st power times 1 minus 0.65 to the 5 minus 1 power. Oops. Okay, so up here we got 5 factorial. And this is again the combination formula that you saw earlier, okay? And this is 1 factorial, and then you get 5 minus 1 factorial times 0.65 times 0.35, and 5 minus 1 makes 4. So you get 5 factorial over 4 factorial times 0.65 times 0.35 to the 4th power. Okay, now it's a lot going on. 5 factorial divided by 4 factorial is just going to be 5 when you simplify that, okay? You can do that with the calculator. 5 times 4 times 3 times 2 times 1 if you want. Divide by 4, divide by 3, divide by 2, divide by 1, that makes 5. And now we multiply that by the 0.65. And then we also got to multiply that by 0.35 to the 4th. And actually, with my calculator, it's easier if I type in 0.35, raise it to the 4th, multiply by 0.65, and then times 5. So that's our probability for the event that we have 1, roughly. And then for event 2, you just go back through the formula and do the same thing. Plug in 2, okay? So 5 times 4. I'll do that real quick. Oh man, it's hard to do in my head. I'm doing 5 over 2, the 5 choose 2 part. 5 times 4 divided by 2, so that's going to give us, we're going to do 10 times 0.65 to the second power. Wait, yeah, 0.65 to the second power. Multiply that by 10, and then we're going to have copy that to my clipboard. And then I got 0.35 to the third power this time. So that's my probability when x equals 2. Okay, so in black here, well, as soon as something cooperates, I can type it in. I'll just write it. 0.18115. Add these three up. That's our probability that it's something less than 3. So a bit of a doozy, that problem. A lot to do there, right? So 0.23, 3 decimal places, so I'm going to say 0.235.